Welcome to The Future Unleashed from Lincoln College, Oxford. I'm your host, Helen O'Hara, and joining me today is Dr. Adam Camilletti. A physicist and engineer who now works at Airbus Defence and Space, Adam specialises in systems engineering, developing spacecraft and technology for both the European Space Agency and NASA missions. He's worked on missions to the Moon, Mars and Venus, as well as on Earth-orbiting satellites that help us understand our own planet. Today, we're in the main reception room at the Rector's Lodgings at Lincoln College. This is the residence of the head of the college. These lodgings were built as part of the college's 500th anniversary, so nearly 100 years ago, at a cost of £11,500. Rector Munro and his family were the first to live here in 1930, and 8 rectors have lived here since. The lodgings were designed by architects Reed and MacDonald of London, drawing on the English Renaissance style, which was very fashionable at the time. And this drawing room is used as a private space for the rector and his family, but also for college functions. So, welcome back, Adam.
Thank you very much.
So you studied physics at university, including your DPhil here at Lincoln. So what drew you to spacecraft specifically?
I think it was probably something as simple as watching Star Wars and Star Trek when I was growing up. You know, really got into it from a young age. But I also remember, I think my mum was very interested in the space race. And I remember as a very small child, we had a big poster of the Apollo astronauts up on the wall. And I think that really got to me at a young age. And then as I grew up, I remember seeing images from the Hubble Space Telescope. And that kind of really amazed me and intrigued me. And from there, it was kind of a slippery slope.
I love the idea of it being a slippery, oh no, I've accidentally ended up here. But you've worked on craft that explore other planets in our solar system, but also, which is I think really fascinating, on space missions focusing on Earth, which maybe people don't sort of think about. But at the European Space Agency, you worked on Sentinel 3, didn't you, which focuses on our climate and sort of measuring sea and land topography. So how do satellite networks like that help kind of manage the future of the planet?
The Sentinel-3 spacecraft is part of a whole system of satellites called Copernicus, and they monitor different aspects of the Earth's climate. So Sentinel-3 has got a whole range of instruments on it, including ones that look at the atmosphere, but also sea temperature, for example. Other ones look at the amount of CO2 or methane in the atmosphere. Those gases can contribute to global warming. The temperature of the sea can affect weather patterns and overall climate change. So the data gathered by those satellites can then be used by scientists all around the world to better model the climate and predict how the climate is going to change, what we need to do to adapt, what we can do to mitigate the effects of climate change.
But it is still a risky business, like space as a thing. I mean, you know, many Mars probes have crashed or failed to land properly. Obviously, we've all seen, you know, tragedies in you know, the manned missions. Why is there such a failure rate? Is it just it's very hard to do?
It is very hard to do. You're absolutely right. I think the failure rate is probably not as high as people perceive it to be. It's just because when things fail, they're dramatic. A rocket exploding or something like that, makes headlines, whereas just a satellite smoothly going into orbit doesn't. It is really difficult to put something in space. First and foremost, we've got to understand the space environment is not benign at all. Obviously, there's no atmosphere. A human couldn't survive there. But there's also radiation from the sun, radiation from other parts of the universe. Those are damaging to organic life, but they can also disrupt computers and cause them to malfunction. The temperature in space can vary dramatically. As a satellite sees the sun, it can warm up, and then if it goes into shadow behind the moon or the Earth, the temperature can drop by hundreds of degrees. So that cycling of temperature is very punishing on materials, on electronics, on absolutely everything. And before you even get into space, you've got to survive the vibration and the shocks caused by the rocket launch. So if you put all those things together, it's extremely difficult to build something that is robust to all those aspects. We're really good at doing that. But if you're launching to somewhere like Mars or Jupiter, where we don't have quite the understanding of the environment like we do around Earth, you're dealing with huge amounts of uncertainty. If you're trying to land something on Mars and you're trying to come in through the atmosphere, you try and brake using the atmosphere with parachutes, to increase the drag to slow your spacecraft down. But we don't know how thick the atmosphere is going to be. Mars has a climate, it changes. If you come into a thin bit of atmosphere, you don't slow down as much as you think, and then you can crash into the surface. So there's all these aspects that have to be considered, and that's why it makes it so challenging.
So what do these kind of missions teach us? Like, is it about our planet, our solar system? What are we learning typically from some of the missions you've worked on?
So starting off with something like Sentinel-3, an Earth observing satellite, that teaches us about the Earth's climate, the atmosphere, how it's changing. Other Earth observing satellites look at things like ice thickness at the poles. So again, that's related to climate change. Other ones can be of use in a disaster zone. So imagine an earthquake has struck. High resolution imagery of the ground can be used to understand where the worst devastation is. It can also help rescue crews understand, well, okay, that motorway is impassable. We can't use that route to get to the disaster zone. Moving further out, if we look at planetary exploration, a good example is Venus. Venus is often called Earth's evil twin. It should be a lot more like Earth, but actually it's got a terribly thick atmosphere. It's acidic. The pressure at ground level would just crush a normal spacecraft, and we don't really understand why that is. And by monitoring that and sending probes to that, it better improves our understanding of how planets formed, how atmospheres behave, and that can help us back on Earth. If we look further out into the solar system and into the universe, we can see all sorts of things going on in the universe that we don't really understand. So galaxies don't rotate with the speed that we think they should if we model them using the observable mass in the galaxies. And this led to the idea of dark matter. We believe that most of the mass in the universe is dark. We don't know what it is. It could be a whole new subatomic particle we haven't discovered yet. If we do discover that, who knows what it's going to lead to in terms of technologies, our understanding of the universe, so on and so forth.
I mean, space exploration, people think of it being, Russians and Americans in spacesuits in the 60s, and it was the preserve for a very long time of the governments of superpowers, essentially. Nowadays, that seems to be maybe changing. Companies like your current employer have long worked with governments, but are now working with private entities as well. So how's that changing, this sort of commercialization of space?
Yeah, you're absolutely right. Up until relatively recently, space was the preserve of governments and sort of government bodies like NASA or European Space Agency or UK Space Agency. Now, yes, there's private companies. Everybody knows about SpaceX, for example, is the most prominent example. They are now taking over some of the tasks that would have previously done by NASA. A recent example of this is a lunar lander made by Intuitive Machines that landed on the moon in February of this year, 2024. Now that was funded by NASA, but they allowed a private company, Intuitive Machines, to do the landing, to build the spacecraft. They essentially gave them the money and said, we want you to land this instrumentation, but how you do it and the design of your spacecraft is basically up to you. I think NASA said the exception to that is anything to do with safety, but other than that, it's up to you. And they're doing that more and more. The governments are backing off from that sort of thing because they believe that private industry can do it more efficiently, and government bodies will concentrate on things where perhaps private industry doesn't see a business model. So an example of this would be James Webb Space Telescope. It's difficult to imagine a private company building something like that because how would they make the profit? Where's the business model? Whereas landing something on the moon or putting something into low Earth orbit where there is a business model, maybe it's internet from space, maybe it's mining on the moon, there's a recognition that private enterprise can probably do that more efficiently than government can. So we're seeing this change whereby it's almost low Earth orbit, the moon, utilising resources, internet from space, imagery, that sort of thing is going to be done by private enterprise. The really cutting edge, investigating the universe, looking out at other planets, other stars, that's what governments and the traditional space agencies are going to concentrate on.
How far do you think we are away from mining the moon?
That's a great question. To be a really sort of profit-making commercial enterprise, I still think that's decades away. But the initial prototyping of that and the demonstration of the technology and proving the feasibility of that, that could happen in a much shorter time scale, years to a decade, I would say.
Yeah, wow. And the cost of this has come down, hasn't it? There have been, discussions, a lot of, reusable rockets and reusable launch systems and that kind of thing. That has massively reduced the cost of getting something into space. Is that correct?
Yeah, absolutely. By more than a factor of 10. The cost of launch has come down by more than a factor of 10. Mm. And that really does open up space to, companies and organisations who otherwise most of their budget would have just been spent on procuring the launcher and not developing their product. Now that launch cost is so low, it makes it possible. You can book a slot on a SpaceX launch for not that much money, and that means you can then concentrate on what differentiates your company from the next one, your product, your instrumentation, the service you're going to send back.
I guess the flip side of this is the question of kind of space junk or space debris, certainly. So if we have thousands now of satellites in Earth orbit, some of them long defunct, there is a danger, isn't there, of them crashing into each other, them creating problems for other items that we now want to send in orbit. Is anyone worrying about this stuff? Is there anything happening about that?
Yeah, absolutely. It's a really, really hot topic at the moment. It's a really massive topic because the governments are extremely worried about it, because we all depend so much on satellite technology now. Most people don't realise it, but we interact with data that's come via space or from space dozens of times every day. An example would be, Google Maps or something like that. It's all dependent on GPS satellites, but telemedicine, internet banking, all of this depends on satellite technology. So we all depend on that. If there's a huge amount of debris orbiting the Earth, and that drives from bits that break off launchers launchers are rockets that are basically staged, and the stages break apart as they go up through the atmosphere, and that releases debris. You've got defunct satellites up there, as you mentioned. If any of those satellites collide with another satellite, they produce huge clouds of debris. And each of those pieces of debris can then cause another collision, and that may produce tens or hundreds of other pieces of debris. So you get this exponential growth, potentially, of debris. And this is the so-called Kessler syndrome. It was quite famously covered in a film called Gravity with, I think, Sandra Bullock and George Clooney a few years ago, which have some queries about the physics in that film. But it's a really good demonstration of what the Kessler syndrome is, where one collision sparks a whole bunch of other collisions, right? Governments are moving towards regulation so that any spacecraft that's launched from their country has to meet certain requirements about how you dispose of that spacecraft at the end of life. So, for example, when you're working out how much propellant you need on that spacecraft, you need to reserve enough so at the end of the mission you can bring that spacecraft down into the Earth's atmosphere, generally over the Pacific Ocean, where it's not going to hit anybody. It will burn up during the atmosphere, and any bits that do make it through the burn up phase will just splash into the ocean. The problem is there's already a whole bunch of junk up there. Old satellites from the 50s, 60s, 70s, which weren't deorbited, and they're floating around, and you just have to avoid them. Now, we can track them from the ground and from space. There's still an issue as it gets more crowded, because everybody's having to move around to avoid them. But what's even more serious is there's a huge amount of very small debris, sort of 1 centimetre size debris, which we can't track very well. But it's orbiting at something like 17,000 miles per hour. And just to put that in context, speed of a bullet is about 1,800 miles per hour. So it's 10 times as fast as the speed of a bullet. And for those of you who remember your high school physics, kinetic energy goes as the square of speed. So if this is orbiting at 10 times the speed of a bullet, it's got 100 times the amount of energy. So something 1 centimetre hitting you at that speed, there's a huge amount of energy in that. It can disable a satellite or even destroy a satellite. And those untrackable debris is an ongoing problem that is yet to be solved.
That's slightly terrifying. I'm only just overseeing gravity, to be honest. So is there a way to make space missions more sort of sustainable? You know, it's something we talk about a lot in every other industry, but you see these huge rockets and it doesn't seem to always apply to space. Is there a way to make things a bit better that way?
Yeah, absolutely. So if we start with the rockets and sort of work our way up, and we'll use the example of SpaceX again, it's very much in their interest to make those rockets reusable because it's very costly every time to build a new rocket. So not just for sort of ecological reasons, there's an incentive for them to make their rockets sustainable. Over and above that, you know, if we think about not cluttering up orbits and making it sustainable, that's also in the satellite operators' interest because they don't want to lose their satellites due to impact strikes and things. So we are seeing some of these big satellite constellations taking a very active interest in being sustainable. So an example is, instead of launching into your final orbit and then turning on the satellite to find out it doesn't work, you launch to a lower orbit where the atmosphere is thicker. If it doesn't work, the satellite doesn't work, it will rapidly deorbit itself just through atmospheric drag. You do your what's called commissioning, your checkout of the of the satellite in that lower orbit. If everything is fine, then you orbit raise to the operational orbit, and it's good. You've sized the satellite and the amount of propellant correctly, so at the end of life you can deorbit it. So that's kind of a sustainable way of behaving. Whereas previously it would be very much use a one-shot rocket, launch the satellite into orbit. If it doesn't work, then it's just stuck there and it's someone else's problem. So we are seeing a more sort of sustainable long-term ethos creeping into the behaviour of these companies.
And another way that people are sort of offsetting some of the cost, obviously, is countries working together. And we've seen this historically for a long time, with the UK working with ESA maybe, or with NASA and so on. There have been tensions here on Earth. Is that changing how countries work together in space? You know, we've seen as ESA EXO Mars program has kind of run into some difficulties because of the tensions with Russia. You know, is this kind of a worry, I guess, going forward with these big, huge projects?
It is definitely the example you gave. The European Space Agency ExoMars program had a rover. In fact, one that I worked on in Stevenage called the Rosalind Franklin rover, and that was a fantastic. It still is a fantastic scientific mission to Mars. It's got a drill on it. It's going to drill down 2 meters below the surface of Mars looking for life. And that was a collaboration. It was ESA-led, but it had NASA instruments on it. It had Russian instruments on it. And it was going to be landed on the surface of Mars by a Russian lander. Since the war broke out in Ukraine, ESA's ceased collaboration with Russia on that project. And so now the mission is delayed while ESA with NASA builds its own lander. So it is disrupting things. That mission was ready to go and now it's delayed by significant number of years, something like 5 or 6 years. On the other hand, collaboration is still going on in the International Space Station. You've still got Russian cosmonauts up there with US astronauts and European astronauts and astronauts from all around the world. So there are glimmers of hope that some level of collaboration can continue, but it is disruptive and it will continue to be for the foreseeable future.
And there are more countries now, am I right, with space programs? So there's something like 70 countries worldwide?
Yeah, absolutely.
Amazing.
Absolutely. Yeah, there's a lot of new entrants into the space race. The UK has long been a space actor. We've been building satellites for decades. We did have our own rocketry program back in the 50s and 60s, and we've now got a new one. So the UK launch from Scotland should take place in the next this year or next year. You've got countries like New Zealand, Australia have launch programs and satellite programs. You've got countries all around the world who are developing their own satellites and wanting to get into space because it's seen as, you know, somewhere where you can innovate. There's so much potential for services, for pharmaceutical development, for what you call in situ resource utilization, so mining the moon, mining asteroids, all sorts of things. Space tourism is another one. So yeah, over the past decade, there's been a huge uptick in the number of countries and the number of companies getting involved.
That's pretty exciting stuff. But I did want to ask about the UK specifically because, you know, for a small island that maybe doesn't have the weather of Cape Canaveral, you know, historically punched above its weight, I would say, in the space race. Is there a value to the country beyond just expanding knowledge and being seen to be part of the system?
If I remember the figures correctly, there was a study that came out, I think, in 2021. And that said the value to the UK economy of the space industry was about just under 17 billion in the previous year. I think it said the industry employed about 47,000 people directly, and then 190,000 people in the value chain, so all the lower tier suppliers and the support services and things. So it's really, really substantial. And as that report's a few years old, so those numbers would have only gone up by now. It's very easy to think that the companies just need physicists and engineers and it's just people in white coats. But most of these satellites, especially the non-mass produced ones, so not the internet constellations, but the science satellites, they're like a Swiss watch. You know, they're absolutely bespoke and they're all hand built. And it's generally not physicists building it. It's generally technicians who are very, very skilled. They may have come from the automotive industry. I worked with one technician who'd spent most of his career working on the London Underground. He was much more adept at building very delicately a spacecraft than I could ever do it. I might be able to design it better, but you need someone who can build it, and that's not me. It's same with the electrical wiring. You need expert electrical technicians. So all these companies need the whole chain. They need designers, they need physicists, they need engineers, but they need technicians, they need electricians, they need mechanical technicians. So there's a huge appeal there for all types of people to get involved in the space race. And I don't think that's really kind of understood. You don't have to have a doctorate or be a physicist to be involved, really.
Just in terms of the UK, you've talked about, you know, a launch in Scotland. You know, is it realistic that we could do a lot of launches here? Is the weather always going to kind of drag us down?
The weather will be an issue, but it is an issue in Cape Canaveral. You know, often launches get scrubbed or delayed because of the weather. So yes, that will be an issue. But we will launch from the UK. We'll launch into a different orbit than you would do from a launch site that's around the equator. So a lot of launch sites are around the equator because that gives you a sort of boost if you're launching from the equator, just due to the kind of celestial mechanics of it. But if you're launching from somewhere like Scotland in the higher latitudes, you're launching typically into a polar orbit. And there are lots of missions where a polar orbit is useful. So there is a market there that those launch sites will tap into. And they do have, as I understand it, they do have orders already for launches. So there are companies out there who want to use that service. It's not sort of make believe and keep our fingers crossed. It looks viable in terms of a business model. What hasn't been demonstrated yet is the launch technology from those sites. But there's a lot of people in the space industry. I think it's quite divided. You know, some people don't see the value in it when you've got something like SpaceX, you can launch very, very cheaply. Other people say yes, but having a UK-based launch capability is strategically important and there's a business case for it. We're not going to be launching, gigantic satellites from there. They're going to be more towards the smaller end. But that doesn't mean they're not important. Those smaller satellites can still have extremely useful payloads on them. They can return useful scientific data. They can, about the Earth, but also they can have sort of astrophysical instrumentation on it, which is useful to our science community as well.
You mentioned strategy there and, sort of geopolitical issues that come into space launches. I mean, even aside from the commercial aspect, are we getting into a sort of new national space race between countries? China has obviously massively developed its kind of space ambitions in the last decade or two. NASA seems to have slightly woken up from a slumber and be a bit more active again and be talking more ambitiously again. So is there a new kind of space race coming?
I think to a certain degree there is. There is competition, not just in space, but everywhere between America and China. And I don't think space is any different. And if you look at what the Chinese have done recently, they have their own space station. So they're very capable of putting people into space. They've demonstrated they've got the technology to do it. They've landed rovers on the moon. They've got a very, very ambitious program of missions to other planets, to Mars and to the outer planets, as well as all sorts of missions in low Earth orbit. I think the moon is a very hot topic at the moment with Artemis, which is the NASA-led program to put humans back on the moon. They've already done one mission, Artemis 1, which was sort of a trial run demonstrating the technology, flew a spacecraft around the moon and then returned it. And sometime after September 2026, they'll look to return people to the moon, which will be absolutely incredible. And I think part of that is driven by a perception of the strategic importance to not let China or anybody else get to the moon first. So there definitely is that sense of a rekindled space race, but this time it's not USA and USSR, it's more USA and partners, I would say, because Europe's involved in that as well, in Artemis as well. And then on the other side, perhaps China.
I mean, you've mentioned putting people back on the moon. There have been, I think, much more serious discussions than ever before about sending people to Mars. Where is the next new frontier? What can we expect in the next few decades?
So I think Mars is very likely. Again, Elon Musk has made no secret of his desire to put people on Mars. And even before that, there are ongoing endeavours to return samples of Martian soil and atmosphere to Earth for scientific purposes. So in fact, NASA has a rover on Mars at the moment collecting samples that a future mission will go and collect and bring back to Earth. So already the focus is sort of splitting, returning humans to the moon in the next 5 to 10 years, and then beyond that, getting to Mars in the decades to follow. What I find really interesting about that is that because we believe that Mars may have harboured life in the past, or could even subsurface still harbour microbial life, you have to be very careful taking anything biological to Mars, or even the spacecraft we send to Mars have to be sterile. They have to be, a lot of money is spent on sterilising them, so you don't transfer terrestrial microorganisms to Mars and they start competing with Martian organisms, or you take the terrestrial organisms to Mars and accidentally think they're Martian ones and think you've discovered Martian life. So you spend a lot of money on sterilising the spacecraft. If we're talking about putting humans on Mars, that's extremely tricky to do. Humans are essentially quite dirty. We carry, a whole range of microorganisms with us. How do you stop damaging the Martian ecosystem, if one exists, if you're trying to put humans there? And I don't think anybody has an answer to that at the moment, but it's being looked into.
So we have a whole field of space ethics to really get into before we can get to Mars.
Yeah, that topic I'm just referring to is called Planetary Protection. It's a great name. But, NASA has whole departments on that. We have some really great experts in the UK on that, at Open University in particular, specialise in that. ESA has a planetary protection officer. So a lot of thought goes into this sort of thing, how not to damage any ecosystem out there. Even though we don't know one exists, we can't assume it doesn't. And it's not just Mars, there are Titan and Enceladus. People have speculated that there could be life there. So those missions need to take this into account as well.
Oh, well, but literally all to play for. I mean, we could be sending people to Mars by the end of the century, mining asteroids, maybe mining on the moon potentially. Yeah,
it's a really, really exciting time, especially with as we talked about earlier, with the sort of uptick in the involvement of private companies and the reduction in cost of the access to space means that, you know, it's not quite at the level where just someone in their backyard can build a satellite, but it means that, you know, student groups, small companies, if they've got a novel idea for an instrument or a service that can be done from space, it's not beyond the realms of possibility to do it now because the cost has become so low.
Okay, but with all of these new actors able to get to space and with the cost having come down the way that it has, is there a danger of it becoming a new sort of Wild West? You know, is there anyone gatekeeping what's being put up there?
Yes, I mean, there is a UN committee on the peaceful uses of outer space. So they you know, consider these concerns regularly. And there are other international committees that work together to issue guidelines on how to use space responsibly. So previously I've been on the UK delegation to the Interagency Space Debris Committee. So that's attended by space agencies from all around the world. So NASA, ESA, UK Space Agency, Canadian Space Agency, Russian Space Agency, Chinese Space Agency, a whole range. We tried to thrash out guidelines about how we should use space responsibly and not fill it up with debris. So how long you should leave a spacecraft up there before deorbiting it, and what constitutes space junk, what's an appropriate way to behave when you're launching your satellites, how much debris you know is permissible to release. And then at the national level, there are regulators who grant licenses. So in the UK, for example, the Civil Aviation Authority will grant licenses for future UK launches, and that will take into account things like your debris mitigation plan, as they call it. What are you going to do with your spacecraft at the end of life? Are you going to deorbit it? I think that the challenge is, because there are so many new actors and countries moving into the space sector who don't have this background, there might not be total alignment from one nation to the next on how they license things, what regulations they apply. So it's not quite as bad as a Wild West situation, but there's still a lot of work to do till we get to a sort of a level playing field where everybody knows what the rules of the road are. As we fill up, or as low Earth orbit gets busier, satellites are going to need to move out of the way of one another. Well, how do you coordinate that? At the moment, it's to say it's ad hoc, it makes it sound really awful. It's not that bad. Most of these space operators know each other and have formal lines of communication. But as you get more and more, you can't count on that. So do we need something like air traffic control? You know, do we need space traffic management, as it's called? And that's something that's seriously being discussed and considered at the moment.
Where would you put the control tower?
Yeah, exactly. Who knows, you know, who would be responsible for this? Because, you know, quite rightly, one country may not want this other country tracking all their satellites and telling them what to do. They've got strategic reasons for not saying what they're doing with that satellite. On the other hand, if you don't do that, you're increasing the risk that just purely by accident your satellite crashes into another one. So there's this balance to be struck, just like there is with aviation. I'm sure, you know, there are rules about the civil aviation and there are rules about military aviation. So it's just exactly how that will evolve into the space domain, I think, is going to be interesting to watch, let's put it that way.
Okay, so there's a couple of questions we're asking everybody. And the first of these is, how would you describe Lincoln in 3 words?
Welcoming, inspiring, and then I think for the final one, I'd probably say fascinating.
So can you explain that?
When I came to Oxford and had I came as a graduate student and had a choice of college, I really wanted to choose one of the smaller colleges because I wanted to go somewhere that was friendly and wasn't overwhelming, and you know, and I'm really glad I chose Lincoln because it really lived up to that. You very rapidly got to know people. You not just people on your corridor or whatever. You got to know everybody very, very quickly, all the characters around college, and I really enjoyed that and still remember them. And coming back now, longer than I'd care to admit after I left, you still see some of them around, and you still really feel part of that community. Yeah. The next one, inspiring. You read about the history of Lincoln and the people who've been at Lincoln. I think Lord Flory being one of the most famous ones. That's sort of, I wouldn't say like drag you along, but sort of buoy you up, because you think, wow, I'm following in the footsteps of these people who've achieved amazing things. And I would say I'm generally a bit of a cynic, but that actually does have an effect. It really does impact you to know you're part of that community.
And then fascinating?
Fascinating, I think, probably ties a lot into the previous point I made. If you look back at the history of all the characters who've been here, the history of the founding of the college is itself interesting. The characters who've been here, the Lincoln Imp, the history behind that, and then some of the, let's say, less academically achieving characters have been here. The famous one like Dr. Seuss, he's a great one. You think, wow, how did he end up at Lincoln? And what was the story behind that? John le Carré as well is another one. All these really, really fascinating characters who've been here. You could just spend your whole time at college learning about the college. So yeah, I just found all that just really, really intriguing, really fascinating.
In this series, obviously, we're focusing on the future. So what advice would you give to young people who are just starting out on their careers as the stewards, essentially, of the future? Working
hard, but not too hard, I would say. It's quite easy, I think, somewhere like Oxford, to see you're surrounded by all these brainy people, everybody's working really, really hard, and just to sort of put your head down and really, really go for it. But there's so much else going on that it would be a shame to miss out on that. You've got to make time for the rest of your life, to make friends, to take advantage of the community you're in college, meet people from other colleges, take part in all the clubs and things. Because one, it's really good, it's for your health, you'll really enjoy it, but you'll also meet people who are doing really fascinating things that you just don't know anything about. I spent most of the year that I was at Lincoln sharing flats and houses with people who worked at the Dunn School of Pathology, who were doing immunology and cell biology and things like that. And it just completely opened my mind to, a world of science I didn't know about. And I met my wife here at Lincoln, and she was studying criminology, which again was something I knew absolutely nothing about. And being from, physics, it's a very, very different subject with different assumptions and ways of working. So, just broadening your horizons in that way and not just focusing on your subject would be the biggest tip I could give.
That's a very good one. Adam, thank you so much.
Yeah, thank you.